Right, what we'd like to do today is to resolve the big problems in science, which literally are not spoken about. So, if we want to say what science does, science resolves inconsistencies. Now, at the minute, human science is horribly inconsistent. Now, it doesn't feel like that because nobody talks about it in these terms. But let's just put it in very plain language. When you go to a university, all the science is spread out into inconsistent departments. Physics goes over here, chemistry over here, biology over here, genetics, and yet, when you look out the window, it's all working together. So, our universities are inconsistent in what they teach. There must be an underlying set of principles which covers everything, if it's all made of the same material. Everything to make a human being is in a glass of milk. And when you put it like that, your brain can really say logically, we're just made of elements, nothing else. So is the solar system. Molecules, DNA, it's all just the elements. And yet, there's nothing in the university which has the common principles of the elements. 1 minute doing the physics, then doing some chemistry, then some biology. Just doesn't work. What this shows you is that how inconsistent science is. So let's just make it plain. This is what we all trust. The laws of physics. Predictable. But there's a problem with physics. Physics is itself inconsistent. There are two different kinds of physics, relativity and quantum mechanics, which are inconsistent. Now that's a problem. If the basic laws on which you think everything is based are inconsistent, it's no wonder the rest of it is inconsistent. So let's solve that problem today. That problem first started to show up with Isaac Newton. His equations work wonderfully for two bodies in space. But when he tried to apply the same equations to three bodies in space, if those bodies are of nearly equal size, they don't work. They don't work at all. The system becomes completely chaotic. He died not knowing the answer, assuming that somebody would solve that problem later. And then we get quantum mechanics. Physics splits into two. Inconsistent. So I've got behaviour here in quantum mechanics which shows that atoms don't behave like solar systems. Solar systems, the behaviour is continuous. A planet can move in any direction it wishes. It can move from here to here. It can be anywhere in between. Atoms can't do that. The electrons jump about. They're inconsistent with this. So the assumption is that one of these is wrong. And that is the typical human failing. To assume it's all going to turn out like the first thing that you find, everything's going to fit with that. And we don't look at ourselves as being flawed fatally with our brains. We think these are absolutely wonderful, but the greatest scientists on the earth make silly human mistakes. So let's expose some of the mistakes that we make and see that everybody makes them. When you get quantum mechanics, you then make computers. And with computers, you can start to study very, very complex systems which are chaotic. Now, you might think that if a system is chaotic, there's nothing that you could quantify about it. And that turned out not to be true. All chaotic systems have a mathematical signature which tells you these systems are all behaving to the same mathematics. So if I've got an explanation for the unpredictable behaviour of matter, an explanation for the predictable behaviour of matter and the probabilistic behaviour of matter in quantum mechanics, why can't I just put the two books together and say, we've done it? Here's why you can't do that. Inside here, for classical physics, we've got cause of action as fundamental forces. Inside here, there's no forces, no mention of any forces. So you can't put them together. They are inconsistent. That's the problem. But maybe we made a wrong assumption at the start. This book should have changed history. All the way through the book, he keeps saying, physics is not appropriate here. So physics isn't appropriate for this book, and yet this is the behaviour of physical matter. And I've got to put these two books together. We'll be making a silly mistake that's stopping us. And that mistake will be right in front of us, and there's good scientists saying this, we're all too close to see it. It's obvious. But when we get used to something, we're very comfortable with it, even if it's wrong. So let's think, what is in this book? What is cause of action? Cause of action in this book is pure mathematics. Same as quantum mechanics. Same as genetics. Einstein famously said, God does not play dice. But genetics is a study of matter playing dice. So he was wrong. Mendel's work with peas, a 1 in 4 chance of having peas with wrinkles or smooth, 50-50 chance of being male or female. Matter does play dice. Purely mathematical rules. So if I want to put these together with the physics, maybe I should change my mind about what a fundamental force is. So fundamental forces. First one's obvious, gravity. But wait. Einstein has already thrown out gravity as a force. Let's see if this one. According to Einstein, gravity is not a force. How could it be a force? How could empty space apply a force to a planet? What Einstein said, it's an effect on the curvature, the geometry. That's mathematics. As far as mathematicians are concerned, mathematicians. So we're getting a clue. There isn't a force between the Earth and the Moon. There's space, and the geometry or mathematics of that space can change and transmit the information between the two bodies. The other is present. Mathematics. Let's think about that in terms of a magnet. How could one magnet apply a force to another magnet without touching? Your logical brain says it can't. But once again, if you sprinkle iron filings around the magnet into the space outside, you see that the geometry has changed. The magnet and the space are following mathematical rules because that's the deal in the universe. That's what it does. And if that is true, there should be lots of other evidence all saying the same thing. The mathematics of life. You couldn't write this book unless life was using this mathematics. How obvious is that? The universe speaks in numbers. The beauty of numbers in nature. We see mathematical patterns all over nature, none of them explained by physics, and those patterns could not be there unless nature was using the mathematics that makes the patterns. How logical is that? Does that make sense?
Thinking of pine cones or
Yes.
a snail shell.
Absolutely.
Where they go around in
Absolutely.
Fibonacci.
Absolutely. Pine cones and snail shells, they're all in there. The Fibonacci sequence is made by the Fibonacci sequence, not physics. So we really have got it wrong. He's got a mathematician. So it's not that the science community hasn't seen that physics is just part of mathematics, mathematical rules, the end of physics. World Beyond Physics, book by Stuart Kauffman, saying we need to get beyond physics as an explanation for evolution. And we do. It doesn't mean that any of the physics is wrong. It means it's just the first layer of laws to which matter and space behave. And those laws seek equilibrium. The laws of biology push away from equilibrium. So I've got a partnership. Bankrupt in Physics. Alexander Unzicker. Very, very good book. So once you've seen evidence like this all put together, we can then start to solve the problem. If we put mathematics as causal in the universe, instead of descriptive, we get science which then all falls together. So the first set of rules to which everything behaves are simple. Predetermined outcomes, single outcomes. It has a paradoxical partner, an infinite number of possible outcomes. Single outcomes, infinite outcomes. Put them together, what comes out in between is reality. And if you now add on to that another layer, which conserves information in DNA, I then start to get feedback loops which conserve information and feed it back into the system, which has unpredictable parts, which you need for biology, predictable parts, which you need for physics. My bones behave as levers, and biology at the same time. Now I can say they're behaving to two different sets of mathematical laws. I don't get into a tizzy. So this is a very, very simple idea which now gives us an explanation for things like molecules, snowflakes. And most people assume that a snowflake is all explained by physics. So let's show you that it's not. So this is taken from this book, which should have changed history. This is on particle physics and quantum mechanics. And Frank Close is very, very honest and states the problem. So he says, for example, molecules of water are free to take up any direction within a warm liquid. But once frozen, they form beautiful structures as exhibited by snowflakes. A pattern emerges in the cold, even though the underlying laws of physics showed no such prejudice for one direction over another. That's it. Laws of physics are completely uniform, so they don't explain snowflakes. They do explain a raindrop, uniformity. But uniqueness, not from the laws of physics. You need the laws of physics for the snowflake to stick together, but that's it. The pattern, I need physics and something else. So if I want biology, I need physics and something else. If I want to explain the solar system, I need physics and something else. The solar system is a self-assembling clock. It's a very accurate clock that's self-assembled from dust. Physics can't explain that. Physics explain why the dust starts to move and form disks and spheres, but the clock, that needs a memory. Now, we don't normally associate the solar system with having a memory, but it does. It conserves information in something called perturbation theory. Every little gravitational tug is conserved and shared out So if I've got 3 planets, this one will speed this one up and slow this one down until they harmonize. That's music. Like music of the spheres. So now we've got an explanation which really does answer all the big problems in science. So let's show you. New map of the whole of science. It's based upon the universe being driven by paradoxes as working partnerships. Not one set of predictable rules, which is what we started out with. Paradoxes, paradox principle. So let's see paradoxes solving our problems. If I look at quantum mechanics, I've got a paradox, which was seen as a problem, now it's a necessity. The Schrödinger equation, which basically describes a unit of energy sitting in space, it's completely deterministic. But if I try and measure that, I get something called collapse of this wave function, and I get probabilistic answers. So we say paradox, we don't like it, that's not science. But it turns out that produces a pattern which is predictable. But no computer or human being can say where each individual electron or photon is going to land on this screen. It's completely unknowable here at that point. So now we've got chaos and classical physics as a working partnership. I get the same thing. I go from completely deterministic answers to completely non-deterministic answers. And what comes out in between? So at this point here, it flips over. There's the 3-body problem that Newton found, and Poincaré proved there were no answers to it. You couldn't have an answer to it because you'd have to have planets which had exactly the same amount of molecules in them. They'd have to be absolutely identical. So now I can see I've got the same pattern. I've got classical physics and chaos sitting side by side, which is predicted in this book. He says, one day this will happen. I've now got large scale relativity and classical physics, which we can now put together as behavior of matter and space with single predetermined answers. That's now in the same pattern as quantum mechanics because I get these predictable patterns here. These are mathematical maps which you get from chaotic systems, which have to have physics in them and chaos at the same time. So if I have a chaotic pendulum, it's still being operated by gravity. So I've got physics. But now I've got physics and chaos, and I get these patterns. So let's have a look at this in biology. Asexual. How many possible outcomes from an asexual creature? It's identical to the parent, so 1. Same as physics. If we go over to sexual, I've got a 50-50 chance, I'm starting to be probabilistic again, I've now got an infinite number of possible human faces. Yeah? And that gives me an even distribution of males and females in the population. I get what I want to increase diversity of matter. So this is very, very important to see that I've got a paradoxical answer which solves all the big problems of science. It's always a paradox. So we can see this in human behavior very, very clearly. If I go over here and you look at men's business attire, male business suits, it's the same. And women wear whatever they want. Even more importantly, you can say the male response to sex. It's just visual, it's set, it's predetermined. Females get to choose. And now that is part of science. So I can say the female choice is a gift straight from the heart of the universe. What a thing to be able to say. How beautiful is that? That's now science. So we take that on board and use it. So what I'd like to do is propose this as a completely new model for science that we start to use. It's already been used to redraw the standard model in particle physics. And it all turns out to be symmetrical. And the way that that was done was to go back to the beginning of science and mathematics, which starts in this book here, to look for what builds mathematics. Because whatever that is will show up in the physical universe as building the physical universe. Sure enough, it does. So in here, this is Euclid's Elements. It was written about 300 BC. It's the only book on the earth which is as true today as when it was written. The only one. It's all still taught in universities. If I go in here and look at one of the first mathematical proofs for prime numbers, prime numbers build all the other numbers. So it's reasonable to assume now that if I look in natural systems of matter, I start to find prime numbers. So here, the numbers 2 and 3, which are the first two prime numbers, build all the other numbers. The first composite number is 4, which is 2 times 2. The first composite element is helium, which has, guess how many particles in the nucleus? 4. The second composite number is 6. And if I take helium and count all the particles that make helium, guess what it is? 6. Now, we don't just find this pattern in the construction of the elements, we find it in every system of matter or information. So it's in genetics, pairs at the bottom, which flip over into triplets. We've found it about 40 times in everything from music to language to art, flowers, anything you can think of, it's there. So that really is the New Deal. And if anybody wants to ask questions and see if we can answer them, because we've at least 10,000 documents now, all catalogued showing that this work is internally consistent, externally consistent, it's the same as what you see out of the window. It's based on reference to mathematical proof, and it's based on reference to scientific experiment, which can be done again by anybody, anywhere on the earth, and get the same answer. It puts science back to basics, where it needs to be. Simple, basic truths we can all trust. Thank you.